Hi there, my name is Cody Mack and welcome to another episode of the 5 Things You Need to Know. Today we're going to talk about why your mixing valve fails to perform. The first thing you should know is that water quality can affect any item in your plumbing system, but can be extremely problematic with a mixing valve that relies on a thermal element or a mixed outlet sensor to sense and control temperature. Mineral deposits, scaling, debris, that stuff's all going to build up in a valve and affect the sensing ability and cause the valve not to perform properly. Follow manufacturer's guidelines to service and clean these valves. Regular maintenance is going to be required with any product in your plumbing or heating system, so don't discount your mixing valves as well. The second thing you're going to want to know is that every manufacturer's mixing valve is going to have maximum and minimum flow rates that you need to be aware of when selecting the proper model. Exceeding maximum flow rates could create a large pressure drop or a loss of pressure in your system, but not meeting the minimum flow rates can cause temperature differences or inconsistent temperature control. In applications with larger flow rates, larger minimum flow requirements may need to be met. One way to do this is actually to use your constant recirculation or your recirculation system for your domestic hot water and size that to meet the minimum flow requirement of the mixing valve. Proper recirculation sizing and piping can make up for that minimum flow rate and provide reliable operation at low flow conditions. Another thing to consider is going to be your system pressures and your not only that, but your pressures on your hot and cold inlets. It's really important to have consistent pressure on each side of the valve. In the case of our 521 series mixing valves, we have a recommendation of no more than a 2-to-1 ratio between hot to cold or cold to hot. If you exceed this 2-to-1 ratio, that mixing valve is not going to be able to perform properly. Now, particular cases where this happens, and it doesn't happen very often, but it's typically where you have too great of a pressure drop across your hot water source. And where you're typically going to run into this is going to be your tankless water heaters and your tankless coils and boilers that you're going to typically see in the Northeast region. So if you have a high pressure drop across those coils to where you're going to have that 2-to-1 ratio exceeded at the mixing valve, maybe you have 25 psi at the hot and 60 at the cold. Again, that mixing valve is not going to work properly, so you're going to want to make sure to keep those passageways in the tankless heaters as well as those tankless coils, keep them clean. The next thing to consider is going to be the temperature coming from your domestic hot water source. Every mixing valve out there is going to have a minimum temperature difference between the hot water inlet and the mixed water outlet temperatures. So if that hot inlet temperature is not hot enough, you might not achieve the temperature that you're looking for on that mixed outlet. Now, in the case where you've got, say, a demand for 120 degrees out of your mixed outlet, you might need to have 135 at the hot inlet or 140, for example. Where we see this as most problematic is typically going to be the startups of a lot of your electric water heaters and your heat pump water heaters. You get those guys installed and they're going to take a long time to heat that tank up. And so if you put a mixing valve on it right away on install, you're probably not going to have that temperature hot enough at the hot water inlet to create 120, because it probably won't even have 120 coming into it yet. So just be careful, again, about your domestic hot water source temperatures. Make sure that they're hot enough to attain that mixed water outlet that you need. For the last thing that you need to know, we're going to switch over to hydronics. We talked a lot about domestic hot water applications. Let's talk about hydronics, and we're going to talk about pump location. Now, what we see commonly is your circulators pumping into your hot or cold inlet of your mixing valves, and this is not going to work. What you need to do is you need to make sure that you're pumping away from the mixed outlet of your mixing valve. That's how it's going to operate properly. If you are pumping primarily, what we see is pumping into the hot inlet, what's going to happen is as the temperature is actually meeting its set point of the mixing valve is going to start to close down that hot inlet side, and you're going to actually potentially deadhead your circulator. Okay, so you want to make sure to pump away from that mixed outlet on the mixing valve, so that way the mixing valve can choose whether to pull from hot or cold, and you're not going to exceed that pressure differential ratio that we talked about earlier. So let's do a quick review of those 5 things that we just went over. The first and most important on any mixing valve application is going to be water quality. You put good in, you're going to get good out. And if you're going to give it poor water quality, that mixing valve is not going to live very long. So the next one, number 2, is going to be your minimum and maximum flow requirements for the application. If your mixing valve is either undersized or oversized, it's going to lead to improper operation. So definitely consider that. The next, number 3, is going to be the ratio ratio between your hot inlet pressure and your cold inlet pressure. Now again, if the ratio is exceeded, that 2-to-1 ratio is exceeded, your mixing valve's not going to work very well. And typically, again, you're going to see this in plugged tankless water heater applications or plugged tankless coil applications where you're going to get that big pressure drop before the mixing valve. The next thing you're going to want to consider is, again, your domestic hot water source temperature. If your domestic hot water source is not producing a hot enough temperature, you're obviously not going to produce any more temperature with your mixing valve, so definitely consider that. And in heating mode, number 5, make sure that you're always pumping away from that mixing valve. And another good thing to remember is anytime you're adding a mixing valve into a hydronic heating application, you're always going to be adding a mixing valve too. So again, mixing valve, add a circulator as well. So definitely keep that in mind when you're doing those hydronic applications. Thanks again for joining us for another episode of the 5 Things You Need to Know. Again, my name is Cody Mack, and we hope you tune in for the next one.